Great. So we are ready for our final session now. I will just invite our speaker, Andrej. But yeah, really great to see so many of you still here. I see some of you have been here for all 6 sessions. So that's a really incredible effort. And I'm sure you've picked up lots of tips for your own projects. So yeah, well done for attending right through to the end. It is great to see you all and all of your questions. Hopefully, Andrej, you can join. I see it says you're getting ready, so that's all good there. We'll just give it another minute or two. If anybody, again, has any questions about the hackathon or generally, if you're looking for a team or wondering about key dates, do drop your questions in the channel. Or obviously you can reach out to me on Discord or even book a call as well. So during this final workshop of today, I'll drop all the links you might need to reach out to myself in the chat. So please do feel free to let me know if you have any questions, or even if you're just starting to build your projects. I'd really love to know what you're building. Excited to see which bounties you're targeting, and yeah, just chat about your projects in general. So I was just going to say, Andrej looks like he's joining, and here he is. So it's really great to see you. How are you doing?
Likewise, thanks for waiting for me. First of all,
No problem.
I had troubles finding the background, but yeah, really excited to participate in this event.
Perfect. Well, yeah, sorry we've overrun by a few minutes, but I hope you can manage to share your screen okay, if you would like to do that, and then we can get going. But yeah, one final time, I'd just like to say thank you to all of the participants today for your questions, and we're delighted to have Andrej here today from Chainlink to finish out the workshop sessions.
Cool. Yeah, so you should be able to see this GitHub page, right? CCIP Cross-Chain NFT. Perfect. Okay, so today, first of all, my name is Andrej. I'm a developer at Chain Protocol Chainlink Labs. And today I'm going to showcase to you how you can build using Chainlink CCIP. So Chainlink CCIP is a brand new product launched by Chainlink Labs during its CC, so pretty new. So if you're not sure what CCIP is, you can go to docs.chain.link. This is the official page for Chainlink documentation. Over here, you can find the CCIP tab, or if you scroll down here, you can find the CCIP as well. Also, there's like other Chainlink products there. But when it comes to CCIP, you can just click this page and it will navigate you to the Chainlink CCIP documentation, where we will spend a lot of time during this demo. So today we're gonna do a cross-chain minting on an NFT from one chain to another. We're gonna use this GitHub project. So if you want to get familiar with the code base up front, feel free to git clone it. But don't worry, I'll do the same step by step with you. But first, before we start with the actual workshop, let's first explore why we need CCIP at first place. So at this link, this is a Git book specifically created for the CCIP masterclass, where you can find how CCIP works, how to use it in your projects, how it works under the hood, and a bunch of exercises for you, where you have like step-by-step instructions in Hardhat, Foundry, and Remix if you want to build using Chainlink CCIP. So we're going to briefly go through the Git book just to cover some basic concepts, and then we're gonna spend the majority of time on documentation and GitHub project itself. So CCIP exists. I need to move this as well. So CCIP exists because of the so-called interoperability problem. So interoperability is basically ability to exchange information between different systems or networks, even if they are incompatible between themselves. Imagine Twitter, for example. You have Twitter as a web application. You have Twitter as like iOS or Android app, and it's all getting data from some centralized servers. So when it comes, let's imagine that that web app is some JavaScript framework like React, Vue, Angular, whatever. Then Android application is written, for example, in Kotlin, iOS in Swift, and then on backend they have Java, for example, or some other backend language. So these technologies are incompatible by design between themselves, but we found a way to connect them, to combine them, and we have Twitter as a functional application as a result. So when it comes to blockchains, CCIP aims to do the same. So currently, if you take a look of a bunch of blockchain solutions, you'll maybe heard terms or phrases like layer 2, layer 3, layer 0, whatever. The thing is that in reality, still, blockchains are kind of like isolated islands that cannot communicate between themselves. So blockchains cannot communicate with an off-chain world, and also it's really hard for them to communicate between themselves. What I mean with communicating? Well, getting info about some smart contract or some other account from a different blockchain. So to solve that issue, different blockchains or different projects started to create something called the bridge or bridges. So the problem with design with bridges is if you want to transfer your tokens from one blockchain to another, basically you're going to lock it on one side and then unlock it on other side. The thing is that they are heavily centralized. Most of them are heavily centralized because you're giving your asset to some centralized entity, and you're hoping that after some time frame, it will appear on the other side. And here, if you take a look at CCIP intro video by Patrick Collins, you can see like a tiny meme created by him where he is like praying for his funds to appear on the other side. So to make this more decentralized or completely decentralized, better to say, the solution is Chainlink CCIP. So Chainlink CCIP stands for Chainlink Cross-Chain Interoperability Protocol, and it's like a simple single interface for communicating between multiple blockchains. When I say multiple, I mean by blockchains that are not only EVM compatible, but also non-EVM compatible. So everything comes in because CCIP only understand the language of bytes. And I'm gonna pretty soon explain what I mean by that. But first and foremost, if you take a look at this previous slide picture, where we have like a representation of bridge, in CCIP terminology, we have something called the lane. And a lane is a unique pathway between blockchain A and blockchain C on this image, which is used for transferring messages, tokens, and data. The thing is that it's a unique pathway because in CCIP, all these blockchains have a unique chain selector, which in Solidity is represented as a UN64 number. And you can find all of these chain selectors on documentation. So if I go here, for example, Chainlink CCIP, over here, there is a supported networks tab. If I click to supported networks, let's say I want to check what's going on with Ethereum mainnet, right? Or let's say Ethereum. Yep.
So, sorry, we just had a question. If you could share some of these links for people to look through whilst you discuss them on screen, would you be happy to share some of these in the chat?
Yeah, sure. So let's go back. So Chainlink CCIP, this is the official documentation. I'm gonna.
Amazing, thank you for that.
Yeah, I just need to find how to paste it.
So chat's on the bottom right.
Chat, yeah, okay, cool. So Chainlink CCIP, this is the repo that we are gonna git clone and try to use today, and also the Git book, if you want to take a look as well. Okay, cool. Let's go back here. So Chainlink CCIP documentation supported networks. We want to explain what the lane is, right? And I said that all these CCIP supported blockchains have a unique chain selector, which in Solidity can be represented as UN64. So if I go back here, let's say, okay, what's Ethereum mainnet parameters? Chain selector is this thing. So 5, if I zoom a bit, so 509, whatever. So this is a chain selector, right? And this is an example of Ethereum mainnet to Optimism mainnet lane. How? Because if I go to Optimism mainnet, there is a chain selector for Optimism mainnet, right? So there is a lane which know that if you're sending from 005, whatever the name of the value of the Ethereum mainnet lane is, to Optimism lane to 373, this is just dummy stuff. Basically, it will use this lane, right? And that's pretty much it. So that's a lane in CCIP terminology. Again, unique pathway from one blockchain to another. If I now want to send messages from blockchain C to blockchain A, I need to use a different lane. So if you want to support a new blockchain, for example, one will need to deploy actually 2 lanes, like a bidirectional lane. And this is how this looks in reality. So multiple pathways, multiple lanes, unique pathways between different blockchains, which you can use for transfers. So why is that? This is just a security first design, because if there is a black swan event or there is a major hack or problem in a lane, only one lane will be affected, not the whole protocol. And this design is just to minimize risks. Okay, so there's like a bunch of lanes now. I want to send a simple CCIP message. How I can do that? How is that possible? Well, if I take a look at this image now, on each CCIP supported blockchain, there is one router.sol contract per chain. And the only purpose of router contract is to successfully deliver your message from one chain to another. So router will use the CCIP box, which we currently can look at it as a black box. So CCIP will do its stuff. We can explore it later, what it was doing. But basically, router will route the message through these different lanes and send it successfully to the receiver, right? Okay, so what you can do with CCIP? Well, with CCIP, you can transfer supported tokens, send any kind of data, and send both tokens and data. What I mean by transfer supported tokens? That means that natively you cannot transfer any token because for you to be able to transfer tokens, that means that you need to have token pools on both blockchains. And to have token pools on both blockchains, basically tokens needs to be trustworthy, not be scam tokens and stuff like that. So that's why you can transfer like supported tokens. But basically, you can transfer tokens. You can send any kind of data, and by what I mean by any kind of data, literally any kind of data. If you take a look at this message right here, any kind of data can be a simple string, like hello world, for example. Data can be some primitive Solidity data type, like address or Boolean or whatever. Data can be a complex Solidity struct. Data can be a function selector that you want to pass to other chain, and then that destination contract on other chain will execute that function, etc., etc. So literally anything, because we can transfer actually only bytes, and CCIP understand only bytes. That's why you can send any kind of data, because if you want to send a hello world string, you need to type abi.encode that string, so it will convert your string to data, and then on the destination side, you're gonna ABI decode it to get the string, and then that you can do for all data types. So you can encode complex struct, you can do ABI encode pack to encode function signature, function selector with parameters, paste it to the other side, execute it, etc. So why that can be useful? Well, imagine that you have like a cross-chain DeFi saver protocol, right? And you have liquidity only on one chain, and you have multiple open positions on multiple blockchains. And you use Chainlink automation to create like a automation contracts or bots to monitor your positions. And let's say that one position is close to liquidation on some other blockchain. So your bot contract, your monitor contract, will automatically pick up that and send the CCIP message to your smart contract on a chain where you have your liquidity, your money, right? And it can encode some simple Solidity struct, like send me this amount of this address, this token, to this address really quickly, fast, help, whatever. And it's gonna be like a simple encoded Solidity struct. Third thing that CCIP can do, it can combine both tokens, transferring tokens, and data. So coming back to cross-chain DeFi saver, now my smart contract on liquidity side, where I have all of my tokens in it, will receive that message, and then it can create another message, like a replay message, where it will send tokens they want, my bot monitor want, and also simple text or simple struct saying like, hey, I send this amount of this token to you because of this image, this message, blah, blah, whatever, and send it back. So you can combine all of this stuff, right? So let's now, finally, who can be sender, who can be a receiver? Well, all combinations are possible. You can send messages from externally owned account to externally owned account. The thing is that if your receiver is externally owned account and you're sending both tokens and data, only tokens will arrive. Why? Because to handle data, the receiver must be a smart contract that implements CCIP receiver.SL. Otherwise, it will not be able to receive data, but tokens will still arrive. So if I have a situation where I'm transferring tokens from one externally owned account to another externally owned account, that's, well, CCIP-powered bridge. Like, you can bridge tokens. And it will arrive in a completely decentralized and a secure way, and it will arrive pretty fast, actually. So if I'm doing external owned account to a smart contract that implements CCIP receiver, well, I can do both data and tokens. Also, other combinations are possible: smart contract to external owned account, and finally smart contract to a smart contract. And that's what we're going to do today. We're actually going to deploy one smart contract on the source blockchain, another on the destination blockchain, and that on the destination blockchain will mint a new NFT. Okay, let's now finally start with this example. So at this URL, I pasted in the chat, or you can find it at GitHub. It's under smart contract kit organization is CCIP-cross-chain-NFT. It's a simple project that demonstrates how to mint an NFT on one blockchain from another blockchain using Chainlink CCIP. And so let's first explore it a bit. So this is a hardhat project, right? So you will need to have Node installed. If you want to try a similar thing, there is a CCIP starterkit-foundry, and under example number 7, you'll find a similar example like this. So you can see how you can do the same thing in Foundry. But let's now focus on Solidity smart contracts. It doesn't matter which framework you're going to use. So here in the README, after the install instructions, which we will cover, you have, again, a brief explanation about what Chainlink CCIP is. We covered that. And finally, this is the thing that we are going to build. So basically, imagine that you have, again, your tokens, your liquidity on one blockchain, and you want to mint an NFT, which unfortunately is part of the collection that is deployed on another blockchain. So normally, you will need to bridge your funds using traditional bridges, wait for like 20-ish minutes. That's usually the time needed for tokens to arrive on the other side. Mint an NFT, spend those tokens for fees, and if there are some tokens left, you need to bridge them back to your original chain, and bridging back usually takes around 7 days for most bridges, which is not ideal, right? So what we're building here is a simpler version of solving this problem. So this is a CCIP which we can, we can look as a, let's do it like this. We can, for now, use it as a black box. And I said there is a source router and destination router on both chains. So I'm going to create, okay, let's zoom out this a bit. Okay, cool. So I'm going to create a source minter smart contract, which will, as a data, send ABI encode with signature, and I'm going to encode the function signature, which is mint, with my message.sender, which will be my address when calling, and send that bytes data using CCIP to the destination router, which will receive this, decode it, and call. You can see here, destination minter will call the actual mint function on my NFT, which will mint a new NFT. Okay, so that's our plan for today. And let's now see how we can do that in practice. So I'm going to zoom this out a bit. I will need to share my terminal as well. So that's what I'm going to do now. If we have any more questions, I'm going to quickly monitor the chat. Okay, links, lanes, perfect. No questions for now. That's great. So I'm going to share my terminal now. So Windows, okay. Okay, you should be able to see my terminal. Yeah, that's great. I'm gonna just, yeah, I'm on a desktop. Perfect. So what I'm gonna do, I'm gonna git clone the project we just saw. So to do that, yeah, go back here. I'm gonna type git clone and this URL. So I clicked the green code button on the GitHub, which gave me this URL. Basically, you can do it even without this .git, so it's basically gonna be cloning the web page. So that's also possible. So I'm gonna just hit enter. Okay, okay. I need to. I'm gonna CCP. Okay, I have already this folder. Sorry about that. Okay, I'm gonna repeat the process. So git clone cross-chain NFT, and I git cloned the new project. So I'm gonna cd into CCIP cross-chain NFT, and yeah, that's pretty much it for now. Clear. That's it. Okay, so I'm gonna stop sharing my terminal once again. Okay, so there is a question. To call, will it be necessary to discover the nodes before? How is it located by token? For now, okay, I don't think I understand your question, Ali. Maybe you can rephrase it. But I understood the Kelvin's question. So can we use Chainlink CCIP with external gateways rather than just blockchains? No. For now, you can connect only blockchains. So you can transfer between different blockchains. But you can combine it with different chaining services, which will allow you to connect with the external gateway if that's the use case of your application. Okay, share screen once again. We need this window now. Okay, cool. Let's quickly understand now what we need to do. Actually, I can. Sorry about that. I'm just gonna share the whole thing. I think that's easier instead of just going through this back and forth. I'm gonna share my screen, and then you can see the terminal as well. If you don't see it, please tell me. So first of all, to use this project, we will need to use something called Chainlink env enc package. And what is that? So usually you will, and this is not mandatory for CCIP, by the way. I use this because it's a really great NPM package. So usually when you work with blockchains, you will put your private keys or your node keys or whatever inside .env file, right? But that's the problem because you're storing them in a plain text, and you should make sure that you don't push env file, etc. So this tiny package, it will actually encrypt it for you. So it will be in plain text, but completely encoded. So even if you push it to the blockchain, to the GitHub by mistake, the bots will not basically grab your funds immediately. So to do that, I'll first need to install this package. So what I did, I git clone npm git clone CCIP Cross-Chain NFT. I just need to run npm install. Great. Okay, we can put this here. Okay, we're gonna clear this. And now I want to compile contract. So hardhat compile to see that everything is working as expected. Compiling, that's great. We're gonna touch the contracts really soon, don't worry about that. But let's first go through the usage of the npm env-enc package. Okay, so first of all, if I want to, for this demo, I'm gonna send message from Avalanche Fuji to Ethereum Sepolia because this is the fastest lane, and it will take me like 3 minutes or something. Opposite will take 18 minutes, etc. So this is just for time purposes. So what I need to do, I need to set my private key, right, and also RPC URLs for these two nodes. So how to do that? So I'm gonna do env-enc set password. So I first need to set password, which will be used for decoding these encoded values by the package itself. So input will be hidden, so I can do whatever I want, like this, and hit enter, and that's it. Okay. So now if I want to set something, I'm going to type something like npx env-enc set. And let's say that I want to set the private key. So private key input value. I'm going to just paste my private key. Okay. Would you like to set another variables? Yes. Okay, so I need Ethereum. Actually, I can paste it. So Ethereum Sepolia RPC URL, like this, and also type something. Let's say Avalanche Fuji, for example. Don't worry about it, like Avalanche Fuji. That's it. Hit enter. Okay, I'm done. Hit enter one more time, and that's it. So now this thing generated a new env.enc file, which is also getting ignored. So if I do code like this, you can see that a new file was generated, right? But if I open it, you can see that this is all encrypted values, right? This is not my private key. And if you want to see what the values are, so I can do something like this. Give me a second. So, and like I'm watching this thing. So npx env-enc view, and it will ask for my password, but basically this is some dummy stuff that I typed, even Avalanche Fuji RPC URL, etc. So if I change my password now to something else, and it's a different one, well, you get the point. I need to set my variables once again. So for the purpose of this this demo, I'm just gonna reuse stuff I have here, and this is just to prevent you from seeing my private key. That's the only thing. Sorry about that. Yeah. Let's see how I can grab the whole thing. Actually, sorry about that. Just code env enc, and it will open. Yeah, here it is. And I'm gonna just grab the whole thing, put it here, and that's it. Okay, cool. Going back to the repo now. I first now need to deploy a destination minter contract, and also I need to deploy source minter, and finally an NFT. So destination minter contract is this one, my NFT this one, source minter this one. Let's quickly explore them while we still have time. So my NFT is a simple NFT contract, right? It doesn't do anything. It just mints a new NFT. It uses OpenZeppelin. It has this hard-coded token URI, which is some dummy image in IPFS. It doesn't do much. So here you can do a lot of stuff. You can use Filecoin to store a bunch of data here, or what, like as a metadata, whatever. And then you can use maybe some other chains to interact with contracts, and then display that metadata from Filecoin or on OpenSea, or create some other storage deals. That's totally up to you, whatever you like and want. But this one is, for the purpose of this demo, extremely simple. Destination minter. By the way, it has this only owner modifier, and that's to prevent minting. And in destination minter, I'm creating a new NFT in a constructor, so that by default, the owner will be the destination minter. So it has pretty much nothing. It has this CCIP receiver, which we need to implement on the destination side in order to receive messages, and I inherit that. Here, I just passed the router, and this is the CCIP router contract on a destination blockchain, right? And from this contract, one function needs to be implemented. This is this CCIP receive, which accepts message from a client library, and that's it. So here you can do whatever you want. What I did is I grabbed the data field from message, which is ABI encode function, and immediately I called that using NFT contract, using NFT contract as a receiver, and that will just trigger the mint function over here, and that's it. And yeah, I just emit event. Okay, how I send this? I have this source minter, and basically this is a creation of a CCIP message. So I have a receiver, which is an address, but I need to encode it because CCIP understands only bytes. Why? Because if we want to add non-EVM compatible blockchains or some fancy blockchains in the future, we don't know their address formats. Even on Filecoin, there are multiple address types, right? And they're like different in a length than the 20 bytes on Ethereum, for example. So that's why we have a nice design that can support even Filecoin or even Polkadot or Bitcoin, whatever blockchain in future, right? Then data. So if you don't want to send data, you can just send empty string, and this is sending no data. But here I'm ABI encoding with signature, min function, and passing the address of message.sender as an argument, function argument. Token amounts, I'm not sending any tokens, so I'm passing the empty EVM token amount array. EVM token amount is a simple struct which consists of two fields, address of a token and amount you're sending. That's it. I'm not sending it, so I'm sending the empty array. And finally, actual arguments. This will pick up the default actual arguments, so don't worry about that. Fee token, I can pay for CCIP fees in Link or in a native coin of that blockchain. So if I want to pay fees in Link, I need to provide the address of a Link token. If I paste the address 0, that means that I want to pay for CCIP fees using native coin to translate that to Solidity using message.value field from a transaction. Under the hood, node operators will still receive a Link. And we'll use data feeds to convert native coin to links. This is to calculate the fee amount, so I can just approve a router to spend that amount of link for fees, or if it's a native coin, just send it like this. And this is CCIP send. I just need to call the CCIP send function. I'm pasting here the destination chain selector, that long number, which is like unique ID for a CCP powered blockchain, and the actual message. That's it. So that's the whole thing. Finally, I'm just gonna go through the README, and I'm just gonna show you the steps how to do that. How we're on time, by the way. Are we good, Rory?
I think maybe just a couple more minutes. I know we started late, but I'm aware that some people might have other commitments. So yeah.
Okay, I'm gonna quickly just follow the steps here to deploy, to show this in action, and then we can have some time for maybe questions. It was more important for me to show you how you can use it, and I mean, code works. You can do it by yourself, this thing as well. Okay, so just to confirm, okay, cool. So first of all, I need to deploy the destination minter. So I'm gonna do something like this. So npm hardhat, I have a task for deploying both my NFT smart contract and destination minter, because when I deploy the destination minter, it will under the hood deploy the my NFT contract as well. So npx hardhat deploy destination minter, and let's pass the network. So let's use Ethereum Sepolia as a network because I have OpenSea integration there, so you can see it. Okay, cool. Attempting to deploy my NFT contract on Ethereum Sepolia. Cool. We now need to wait for all these transactions to happen, but yeah. This is just proof of concept to show you that that you can use CCIP with 20-ish lines per smart contract per code. This is extremely simple. Obviously, when you go to the official documentation, there are like a bunch of best practices supported, and you should use that for production-ready contracts. But for getting started, it's extremely easy. Okay, we deployed my NFT contract. Now we need to deploy destination minter. And we provided this address as a router contract, as a constructor argument. And finally, we are now granting the minter role to destination minter contract, etc. So it will be able to mint new smart contracts, new NFTs, sorry about that, when receiving a CCIP message. Cool, everything is green. That's what we want to see. Second, we now need to deploy source minter. So optionally, I can pass router and link addresses manually. I have like a config file for that. But if you want to pass them manually, if we go, for example, to Avalanche Fuji, I can grab the router address here. I can grab the link address here, chain selector, all of that stuff. Tokens I can send. So I can send CCIP BNM, NCL, CCIP LNM. We didn't have time to cover that because we are doing transferring messages, but yeah, you have all of that in Gitbook and official documentation. But okay, if I go back here, where is my terminal? Oh yeah, here it is. So I need to do something like npx hardhat deploy source minter, and I'm gonna use network Avalanche Fuji just because of the speed, basically. So I'm deploying now source minter smart contract on Avalanche Fuji blockchain. And if I recall correctly, this is the only thing that I need to do. Yeah, this is it. Perfect. Finally, before calling the mint, I need to fill sender. So I need to fund my source minter contract with tokens for fees. So I can use even native AVAX Fuji coins or Link. I can go to MetaMask and just send it to my wallet, through my wallet, or I can use this built-in task. So for example, if you want to fund it, what I can do is call this task. So give me a second. So how to see it better. So npx hard hat fill sender address is the source minter. Okay, so source minter is deployed at this address. Okay, cool. Then blockchain is Avalanche Fuji. Then what we have here, amount and pay fees in native. Okay. Okay, this is 0. I'll expand this to have one more 0. So this is, okay, let's do another. So this is 0.1. That should be enough, just to be safe. And I'm gonna pay fees in native. So I'm now attempting to send this amount of native coins. And finally, we can do the cross-chain mint. Okay, cool. So to do that, so npx hard hat cross-chain mint source minter is source minter deployed this thing source blockchain Avalanche Fuji destination blockchain Ethereum Sepolia destination minter, where is it? Yeah, here it is. Destination minter and pay fees in native. Hit enter. And yeah, let's hope that this won't fail because I haven't funded enough. Okay, this looks promising. Okay, so mint request sent. This is a transaction hash. Cool. I now can copy this transaction hash and go to CCIP Explorer. So at ccip.chain.link, this is official CCIP Explorer. So with Chainlink CCIP Explorer, I can here I can pass CCIP message ID, transaction hash, or addresses that interacted with this in this transaction. So what I did, I pasted the transaction hash. So here I can see all the details about my cross-chain message, my message ID, my source transaction hash, my destination transaction hash is not available because of this status that changed dynamically. So it will go through source finalized, through blast, to finally success. So currently, there is something called risk management network, which is a completely off-chain component that monitors what CCIP is doing for the security reasons. So CCIP is now listening for the source chain on Avalanche Fuji. And it's particularly listening for the finalized RPC tag. So finalized means when blockchain is finalized, there is no way for reverting that particular transaction. And we want our transaction to be in finalized blocks, okay? In a block which is finalized, okay, to rephrase. So CCP commit done will listen to that and will report its own version of a Merkle tree of all of these transactions which considered to be part of finalized blocks. A risk management network will do the same, and it will compare that Merkle tree from commit done with its own Merkle tree. And if everything is well, then these nodes in risk management network will vote or curse for the validity of that Merkle tree of that was produced by a committing done. This is off-chain component, right? And if it's okay, it will be blessed and it will continue with execution. If it's not, it will be cursed and the execution will stop here. Finally, if it's blessed, then the execution done will try to actually send the message through the CCIP router on the destination blockchain. So here we have source blockchain, destination, transaction timestamp, from to, destination gas and fee combined. So we can see that we paid this amount for gas and fee, but for CCIP, it's converted to a link. We're not sending any tokens amount. This is data we're sending, and also some other stuff. If you have any questions, I'll try to answer them now while we're waiting for this thing to get finalized. Okay, so that I meant that if one of the blockchain nodes is making bad contracts, how do I know? Let me so unnecessary to discover the nodes. I think I can answer your question like this. So I'm going to go to architecture.
Just to let you know, Andrej, I hate to jump in, but we do only have a couple, well, we've overrun slightly. So
okay.
If we could just wrap it up and share any final remarks or resources which you would like to share, that would be great. And then hopefully we can get any questions answered in the Discord channel after the session.
Sure, perfect. Okay, so I'm going to continue with the conversation on Discord. This is the bigger picture of CCIP. Currently, these off-chain components are handling that transferring of message is successful. And finally, with these contracts here, router will route the destination message to the receiver. So once we have this, okay, this is blessed. After that, it will come to the success. Finally, it will appear on OpenSea. So here we need to wait for basically, sorry about that, for a success here to appear. And we can query that the balance of my NFT of the owner is now 1 instead of 0. And of course, we can see this not particularly nice picture on OpenSea. But yeah, so the last step is basically to wait for blessed to become a success. So thank you again for having me. I'm going to answer all of your questions. I'm going to stop sharing my screen. I'm going to answer all of your questions if there are any on Discord. There is a channel dedicated just for Chainlink's support during this hackathon. So yeah, thanks again for having me. And yeah, see you around.
Amazing, thank you. And yes, I have shared a link to that channel in the chat here as well. So for anybody who does have a question, feel free to use that. And I think Andrej is going to be moderating within that Discord channel. So one final time, thank you very much to Andrej for such an insightful session. And thank you to all of our participants for joining us today. We do have another shorter series tomorrow at 5 p.m. BST. So we'd love to see you all there once again. And of course, the details for that will be shared after this workshop. So thank you very much to Andrej. Thank you to all of our participants. And hopefully we'll see you all in the Discord channel. Cheers. Bye-bye.
Thank you.